Okay, so in this other example, what we're going to do instead of using a share Dropbox folder is we're going to do something that is much more likely to look like something you'd be using in a real production environment. So what we'll do is we're going to use 3 computers for this example. So in this first computer here, what we're going to do is this will act as a server that will save our main repo on the server. So all the other computer will be reading from this remote repo. And that's also the computer that will generate a Mongodb database so that all the artists can read from this database and pull information from it to update their own local repo. So here we have the other computer, the TD computer, where we'll be making all the code and pushing to this other remote computer. And lastly, we'll have what will be our artist computer. So that's where we'll be taking all the information from this remote computer and pulling inside their own new folder so that they can work from what we have specified in the database. So first, let's take a look at the Python API of Mercurials that we'll be using for this training. Okay, so let's take a quick look at the Python API for Mercurial. So we'll just make a new testing file. So new Python file, testing.py. So let's import the Mercurial module. So import hglib, that. And then the first thing you need to do is make a variable link to your repo. So here I have a repo that I'll just copy the path. And let's call this one repo equal hglib. And then you use the open function and you pass the path to your repo. So we'll just use a raw string. So now if we print repo, this, we see that we have a HD client object. So let's do something with this object. So one thing you can do is to just do a print summary. So if we just print this, we have the latest option of where we're currently in the repo. So if we just open Tortoise HD here, so you see that right now I'm at the quick fix change set. So that's exactly what we have here. So if I just update it to maybe updated tools, update, and run this code once again, we see that now we have the info of the current change set. So let's now use the update function that will let us navigate in the change set of our repo. So let's do repo.update like that. And you could either pass one of the tags. So let's do repo update tip. So now we should be updating to the latest fix here. We can also pass a hash. So I could, let's say, copy this, copy the hash, and paste it here as the string. And you see that we've changed in the Mercurial repo the change set. Then the next thing we could do with the API is to clone a repo. So let's say I want to clone this repo next to it. So I'll just go back in the new folder, and let's say I want just to do a quick clone next to this one. So you would use hglib.clone, first argument being the source. So we'll just use this here, and then we'll paste it to something like repo2. So that would do a quick clone of this repo. So let's do this. So if we run this, you see that we have a new folder here, which is a clone of the first repo. So now we could use the push and pull function also. So let's say we just delete this and we open our second clone. Now we could do repo.pull. So that would do a pull from the clone repo. So if we just run this, we've done a quick pull. So let's say now that just to see it working, we'll just go in the first repo, open it in TortoiseHG, and we'll just modify one of its files. So just edit the menu.py. So just change the file real quick. So save this. So now if we go in the working directory, we see we have our modify menu.py. So we'll just do modified, and we'll commit. So now if we open our destination here in TortoiseHG, so let's do the pull. So as we'll be running the pull, you should see this updating with just the fix we just pushed. So we'll just run that. And here we have our modified change set. So we can use the pull, or you can also use push if you want to do the exact opposite, if you want to push it to a remote repo. Okay, so now that we know the basic of the Python API of Mercurial, let's build our database so that we can start to store some change set info inside the MongoDB instance. So here I have the MongoDB app on my desktop. So that's where I'm going to execute the instance of MongoDB from this computer server. And here on the file system, that's where we'll be storing the repo from Mercurial. So that's the folder that everyone is going to read from a network. So let's open a terminal here. And first, let's make a folder where we'll be making our database. So I'll just next to the inside the app, make a new folder called DB, like that. So now let's start the MongoDB instance. So since this is on my desktop, I'll just go to cd desktop MongoDB, and we'll go in the bin folder here. So now from the bin folder, I need to start MongoDB. So let's start Mongo like that, MongoD space, and then we need to specify the path of the database. So --db path, that, and this is inside my users like that, desktop MongoDB, and in the DB folder. So now let's execute this. So now we should have a running instance of MongoDB. So let's connect to it to see if everything is working. So we'll just open this, create a new connection, and we'll just connect to the localhost and save, and click on connect. And now we see that it's working. So now let's test the connection from another computer. So we'll just go on our TD computer. So this one here. So let's open Robo3T, and let's try to connect to this other computer. So here I have already set a connection to it. So the IP of this computer is the one specified here. So now if I try to connect to it and click on connect, now we see that we cannot connect to our MongoDB instance. So to fix that, we'll just go back here and we'll just close the process for now. And we'll just reopen a new terminal. So we'll again go back in our bin folder here, and let's recall our command to start the app. So the problem right now is that when just starting the MongoDB like that, the database will only listen to incoming connection from the local host. So now we need to add another argument to specify that we allow other computer to connect to this computer. So first we need to bind the IP to 0000 so that will allow other computer to connect to this instance. So we'll just put dash dash, and then we'll need to pass the bind IP argument, and then we'll just specify 0.0.0.0 like that. So this will start our MongoDB. So again, if we try to connect from the local host, everything is working. And now if we go back to this other computer and try to connect to it another time, since we've bind the IP to listen to upcoming connection, now we should be able to connect from this other computer as well. So we'll just click on connect, and there you have it. We have connected to our other computer. Okay, so now that we have our running database, let's take a look at the actual init.py file that we'll be using and putting in all of the artist nuke folder. So first, here we are in our td.nuke folder. That's where we'll be building all the code. And then we need to first clone this in the network so that all the artists will be able to clone it also inside their computer. So first, we need to specify a path to this folder inside this computer, the one that is actually kind of our server. So just to show you, if I make just an empty folder here and go back in our TD computer, if we go inside this folder here, that is actually a network path from this computer, you see that we've just have access to the folder we just made on the other computer. So first, let's clone our repo that is currently inside our home folder from this computer to this network path. So we'll go inside here and open HG Workbench. And then we'll clone this to the network server. So we'll just actually go in File and clone repo. So from this repo folder, we'll browse for our network path. So we'll click here. So that's the network path, and we'll make a new folder. And we'll store this clone repo inside a folder called repo. So we'll just double click, select this one, and click select folder. And then we'll clone this to the network folder. So if now we close this and go to the network path, we have our repo that we've just cloned here. So let's take a look at the init.py file. So the first thing we'll do is import the OS and sys module. So this is pretty basic stuff. Then we just need to specify the network path of the remote repo that we'll be cloning from. So the one we just cloned inside the share folder on the network. So you just need to specify the network path to this. So that might change from computer to computer depending on the path the computer needs to see this this path. But normally for a network path it should be pretty standard. But if you that's maybe something you'll need to change depending of the configuration of each computer. So that's the path to get to this repo right here. So here I've made a quick variable to specify. Actually, this is telling me where the init.py file is currently stored. So since the nuke folder might be different from computer to computer, I've just made this quick os path.dir name, and I'm passing this argument here. So if we just copy this here, and I'll just make another quick test file, so new Python file test.py. So you'll see what this is actually returning. So I'll just import sys, and I'll paste this, and I'll open OS as well. So if I just print nuke folder here, you see this is actually returning the folder where this file is currently in. So since the init.py will always be in the nuke folder, this will make sure to return the correct path to the nuke folder depending of the user's configuration. So this is just to make sure that we know exactly where we are in the nuke folder. Then we need to specify where we want to store the local repo. So what we want to do is on each of the artist's computer, we want to store it in a folder called repo inside the nuke folder. So we'll just join two paths. So our nuke folder, so the .nuke folder returned by this line here, and then we'll append repo. So this will return this folder right here. So this is going to be our destination for our local repo. Then we see how that we have a new plugin add path, and we add the side packages folder to the nuke folder. So what will be appending here is something I just for now I've stored here in this various folder. So have the side packages here, and since this is going to use some module to do some action, like I'll be using the PyMongo API to query the database. So we'll need this module. We'll also make sure to have the hdlib library from Python to talk to Mercurial. So since this is not built-in Python packages that is shipped with Nuke, we need to make sure that we'll have access to those Python module. So before importing those two modules right here, we'll make sure that Nuke can see those Python module. So what we'll do is, well, inside this side packages folder, I've copied all those modules that Nuke will need to import those two modules. So basically what I did, I just went in my C drive here, and inside our Mercurial virtual env, if we go in the side packages of this virtual environment, basically I just copied all the module that we've imported and installed with pip. So I've copied those module inside this side packages folder. So we'll have to copy that inside our nuke folder in each of the artist's own nuke folder so that they can make sure they'll have access to this, since we need to have those modules to do all those actions that we'll be doing here. So that's the folder that all the artists will need to copy in their nuke folder first before running this code. So this line here basically just do that. It will make sure that the nuke will have access to those module. So next we import the Mercurial module as well as the PyMongo that we'll use to talk to our database. So now let's take a look at what we'll actually be doing once we have imported our package. So the first thing we're going to check is we're going to verify if inside the nuke folder there's already a repo created. So if I just go on this computer here, we see that inside the nuke folder, that's where we'll have our init.py. So first we'll verify inside this artist nuke folder if there's already a repo created. And if there's no repo created, what we're going to do is clone from the network repo inside our local repo path. So basically we're going to take this path here, specify it as the source of the clone, and we want to clone it inside this variable here that point inside the nuke folder. So if the folder is not there, it means we need to clone the repo first, else we'll just pass and omit the clone option. Then we need to create a variable to our local repo. So using the hdlib.open, we will reference to our local repo. Then we'll make sure that we have all the latest change set that is inside the remote repo on the network. So we'll pull all the change locally. So if anything has happened from the last time we've opened Nuke, we'll make sure that we have access to all those change set. Then we'll create a client connection to the MongoDB database. So what we'll be doing inside the database, we'll be storing the information of the change set that the user needs to update to. So what we'll do first is make a connection to the database. So using the mongo.mongo client, then we specify the IP of the remote computer. So that's the IP to get to database here. So this will make a connection to the database. Then we'll make we'll query the a specific database inside MongoDB. So the database will be called fxphd, and we'll have a collection inside the database called Repo, where we'll store our repo document. And inside this collection, we'll make a document storing the information of the change set. So what we'll let's go in MongoDB and create this document. So we'll just open this. So we'll make our new database. So create database, call it fxphd, like that. Then we'll make a collection called Repo. So by selecting our database, we'll going in the collection, we'll make a new collection called Repo, create, and then we'll make a new document with two properties. So the first property will be the name of our repo that we want to make. So let's say that we will have to, in our pipeline, we'll make one for Nuke, and maybe we want to also store some info for Maya or any different software that you might be using. So we'll specify that in the name property, and then we'll make another property in a document called hash, and that's where we'll store the hash that the repo needs to update to. So let's make this document right now. So we'll just double click on the collections, and we'll make a new document. So insert document. So let's make the name will be Nuke. And then let's make another one called hash. And whoops. For now, let's just put an empty string like that and save the document. So now inside our database, we have this document here. So now that we know that we have this document, let's go back in PyCharm. So basically, yeah, that's what we'll do. We'll connect to the database. We'll do a connection to the fxphd database, then do a reference to the repo collection. And then we want to find the document that has the a name property of Nuke. So since we only have right now one document in the database, this will do a quick query of the database returning this exact document. But let's say that we'll make another one. So insert document. So let's say that you'll also want maybe a different configuration for Maya. So you will make another document and say name. And this will be Maya, that, and you would also have the hash property, and this also would return a property once we set it one inside this document. So we'll just save it for now, and we'll just do a quick refresh like that. So now we have those two documents. So since we're doing a quick find one query on the collection, we want to find the document that has a name Nuke. So this is going to return this document, and then once we have this document, we just want to get the hash property. So since this variable here will be returning the document, now we can just take the doc object and get the hash property. So basically now with the repo object, what we'll do is update the repo to the change set that we have specified in the hash property of this document. So let's for now go in Tortoise HG and take one change set, for instance. So we'll just go in this .nuke, go inside the repo, open Tortoise HG. And for now, let's just take the quick fix hash. So we'll just copy the hash, and then we can manually go here and we'll just edit the document and we'll paste this hash right here. So we'll just click save. So now once Nuke will open, it will query the database for this document and we'll get exactly what we just specified here as the hash. And now Mercurial will update the local repo to what we have specified in this document. And we'll also make sure to pass this optional keyword argument, the clean equal true. So let me show you what this is actually doing. If we just go back in Mercurial and just make sure that we're at this latest change set. So let's just maybe update one of the menu.py. So we'll just edit that and just add a few characters to this comment, and we'll click save and close this. Now we'll go back in Tortoise HG, we'll refresh our working directory. So we see that we've just modified that. We'll just do a quick commit. So quick modif, and we'll commit that here. So now let's say I go back to this change set. So we'll update and update back. So now I'll just re-edit this file. So you see that since we went back, this modification disappeared. So I'll just put something else like that and click save. So now if I click and I want to update to this change set, what would happen if I just click update and click update? You see that we have this message telling us that one of the files that we want to update to has been modified. So now our local version of this file is different than what we're trying to update to. So now Mercurial wants to know what we want to do with this conflict, because now there's two different versions of the file. So we can basically tell Mercurial to discard what we have currently modified locally. So this will trash what we have currently on drive and take what is from Mercurial. We could also shelve it so that we can get back to the modification later, or we could merge the two change together. So in this case, we had to specify what we want, which version we want to use. So using the clean argument, if I just cancel for now, basically we'll do the same thing if I click this checkbox here. So by clicking this checkbox, the clean checkbox, this will tell Mercurial to trash anything that we have locally and take the version stored in Mercurial. So if I just update with discard local change, if we update, we see that now Mercurial has not asked what to do with the local file and just use what it has inside the change set stored in Mercurial. So basically giving the clean equal true argument here, just tell Mercurial to, if there's some conflict between what is stored in locally in the file structure of the user, just make sure to take everything that is coming from Mercurial. So if anything has been modified in the nuke folder, there won't be a conflict happening using the update function of the API. So everything will be trashed locally and be updated to what is stored currently inside Mercurial. Okay, so now that we've finished our init.py, it's time to test it on an artist's computer. So here we are in an empty new folder in this computer. So we'll just open a new browser and go on the share folder on the other computer. So here I have the various folder where I have a copy of this init.py file, as well as the folder containing the side packages that they'll need to run this init.py. So we'll just copy those two and paste it inside our nuke folder. There it is. So now if we've done everything correctly, when nuke will open, it will run this init.py file. And since there's no local repo at first, it will clone it inside this nuke folder. And then it will query the database to see what we have specified in the change set of the document that we have saved. And then it will update it, the repo will update it to this specified change set. And then inside our init.py, we specify that we'll add the new plugin add path to this new repo folder where we have stored all the tool. So let's open nuke to see if everything is working as expected. So we'll just open nuke. So now we should see some folder appearing in our nuke folder as the clone of Mercurial will happen. And here we are. So we have our tool installed here. And if we, for now, just close nuke, we see that our repo folder have just appeared inside our nuke folder. And if we go inside, we have our repo folder with all our tool. So now let's close this for now. Let's open Tortoise HG Workbench here. So now you see that we're at this change set that we've specified in the database. So if we just go once again here on this TD computer, so let's say now that we want the artist to work at this change set. So we'll just copy the hash, and inside our database, we'll just modify our document. So we'll just edit this document, paste the change set, save. And now if we reopen nuke once again, we should see Mercurial updating to this specified change set. So we'll just open nuke once again. And there you have it. So now we see that Mercurial have updated to the change set that we've specified here from the change set. And also the cool thing now is that if we go back to this artist computer, we see that the latest change set that we have is our modified change set. And if we just go back to our TD computer, we see that we have this change set here, but we also see that we have a later change set that we have here that we still don't see in this computer. So to make it available to all the users, don't forget that you'll have to push it to the network repo before the user can pull it locally. So here you will have to make sure to push it here to the network. So now if we go back to the artist computer, since we have a pull request inside the init.py, you'll see that when we'll start nuke, we'll have this new change set pulling from the remote repo. And there it is. So once again, we see that if we take a look at Mercurial, we've pulled this change set, but we're still updated to this change set since we haven't changed the hash info inside the database. So I hope you see how powerful this solution can be in comparison to the Dropbox solution, where we were just linking to a live update of a repo. So using the system, you can specify numerous different solution in terms of software. So for instance, like I just done here, you could have one specific change set for Maya and one for Nuke. So depending of which software you were opening on your computer, your repo will change to the configuration needed for this specific software. So now you could push this a bit further by, let's say you have a specific change set for Nuke 12, a specific change set that you want to use for Nuke 11. You could do it project based, so you could have as a much complex database system for your repo to use when you start a specific software. So just to end this training and show you how powerful this technique can be, let's take a look at those two documents. So what you could do if you have a much more complex setup, you could use document to update multiple library all at once. So for example, let's say that you have one repo for your Nuke tools, so that will be in the Nuke folder, but you're also using other libraries in your pipeline. So maybe one for global Python or libraries used with multiple software in your pipeline, and also maybe some other tool that you're building, maybe an internal software. So when starting a specific software, you could specify multiple repo and how they need to be updated in the context of the software. So for example, here what I've done is two documents for Nuke, but I've specified a different version. So depending of the version of Nuke that I would be starting, multiple repo would be updated differently depending of the version of Nuke I'm using. So I hope you see now the advantage of using a tracking system like Mercurial for, well, first track all your change sets so that you can keep a track of everything that has been done in terms of code development, but also in terms of collaboration with other people, and also how you can manage the context of your code depending on the software you're using.